This is SpaceTime, Series 25, Episode 125. Coming up on SpaceTime, liftoff of NASA's Artemis-1 mega rocket launching Orion to the Moon. The first CubeSat to visit the Moon arrives in lunar orbit, and a solar snake slithers across the face of the Sun. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The world's most powerful rocket, NASA's Space Launch System, or SLS, has successfully blasted into orbit on its maiden flight. The spectacular nighttime launch from Pad 39B at the Kennedy Space Center in Florida carried the Artemis-1 Orion spacecraft on the first leg of a journey that will ultimately return humans to the Moon. Meteorologists with the United States Space Force's Space Launch Delta 45 team, which operates Space Launch Complex 39B at Cape Canaveral, forecast 80% favorable weather conditions for the flight. The Space Launch System rocket and its Orion spacecraft arrived at Kennedy's Pad 39B on November the 4th, where they remained in place, riding out Hurricane Nicole. Following the storm, teams conducted thorough assessments of the rocket, spacecraft and associated ground systems and confirmed there were no significant impacts from the severe weather event. Engineers had previously rolled the giant 98-metre tall rocket back into the vehicle assembly building on September the 26th. That was ahead of Hurricane Ian and after scrubbing two earlier launch attempts, one on August the 29th due to a faulty temperature sensor on one of the SLS core stage's RS-25 main engines, and a second on September the 4th due to a liquid hydrogen propellant leak in an interface between the Space Launch System rocket and the mobile launcher. Prior to rolling back the 6.5 kilometres to the vehicle assembly building, teams successfully repaired the cryogenic hydrogen leak and developed updated tanking procedures. While in the vehicle assembly building, engineers performed standard maintenance to repair minor damage to the foam and cork on the thermal protection system and to recharge or replace batteries throughout the launch vehicle. Artemis-1 had a 2-hour launch window for its 26-day flight into orbit around the Moon and back. The textbook perfect launch was the first leg of a mission which will see Orion travel thousands of kilometres beyond the Moon before returning to Earth.
And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS Orion and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you. Range Weather.
Weather has no constraints and weather is go for launch.
Copy, LWO. And Mission Manager, Launch Director.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis-1.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, Launch Director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis-1.
Copy, Launch Director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD.
CVSC here.
Initiate recording of Orion cameras at this time.
In work.
NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch Director getting ready to get that new T0 time. The poll that you heard was the NASA Test Director's poll.
All right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
Okay, we went straight into terminal count. Control has been given over to the GLS. the ground launch sequencer, a computer and software that is doing all of the commanding and monitoring of the Space Launch System. We'll hear callouts from the GLS operator, Alex Pandalos, as well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction. The GLS is performing up to 100 commands per second, including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers, purging the aft skirt booster with high-flow nitrogen, clear out any hydrogen gas that may be there. The crew access arm is already retracted. When there is crew during Artemis-2, it would happen at T-minus 6 minutes. The base of the mobile launcher, if something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. That sequence start at T-minus 17 seconds. Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization. Firing room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
GLS is go for FTS arm.
The flight termination system is now armed. This is where the RS-25 engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. Up next, GLS fires up the CAPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit Start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test. That can proceed now. The engine's gimbal at the bottom of the core stage. You will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Engines will gimbal. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. All together with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS is go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff, Mission Control Houston will take control of the rocket. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the Autonomous Launch Sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis-1. We rise together back to the moon and beyond.
4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis-1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour, at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis-1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison. Confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis-1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated, and that the launch abort system pyros have fired, separating those from Orion as well. We just heard the call for 3 engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange. We're 4 minutes and 16 seconds into the flight of Artemis-1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis-1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good. Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour. 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight. 5 minutes and 42 seconds into the mission, we are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center. Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds, and about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis-1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight. About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire at maximum thrust. Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down. 30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down. Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour. Continuing to hear good calls here in Mission Control Houston. We're standing by for core stage main engine cutoff. And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The flight dynamics officer reports that we have a nominal main engine cutoff, and we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System.
Artemis-1 mission manager Mike Serafin says the Space Launch System's accomplishment of the first major milestone of the mission allowed Orion to embark on the next phase, that is to test its systems and prepare for future manned missions. Artemis-1 is a critical part of NASA's Moon to Mars exploration program. That'll see humans establish a permanent lunar base and then use that as a launching pad for eventual manned missions to Mars and beyond. Artemis-1 is a shakedown cruise, testing the technology which will be used in 2024 on the manned Artemis-2 mission. That'll see humans return to lunar orbit for the first time in over half a century. And that will be followed by the return of humans to the lunar surface on Artemis-3 in 2025. NASA Administrator Bill Nelson says Artemis-1 is pushing Orion to the limits of deep space flight. 8 minutes and 8 seconds after launch, the Space Launch System core stage achieved MECO, or main engine cutoff, successfully shutting down its 4 RS-25 main engines, which first flew decades earlier on space shuttles. Stage separation occurred 10 seconds later, with Orion and its interim cryogenic propulsion upper stage achieving orbit insertion. After reaching its initial orbit, Orion deployed its solar arrays and engineers began performing checkouts of the spacecraft systems. After a single 90-minute orbit around the Earth, the SLS upper stage successfully ignited for an 18-minute trans-lunar injection burn, placing Orion on course for the Moon and boosting its speed from 28,160 km per hour to 36,210 kph. Orion then successfully jettisoned its upper stage and began its outward coast to the Moon, powered by its European Space Agency-built service module. Over the following hours and days, a series of 10 small cubesats carrying a range of scientific experiments and technology demonstrators were deployed from the upper stage's interstage ring, which connected the upper stage to the Orion spacecraft. An 11th CubeSat will be deployed once near the Moon. Each of these microwave oven-sized satellites has its own mission, designed to help fill gaps in science's understanding of the local space environment, the Moon, or to test technologies for future missions to explore the Moon and beyond. Orion's service module also performed a series of course correction burns, keeping the spacecraft on target. Throughout the flight, mission managers at NASA's Johnson Space Center in Houston, Texas, are conducting ongoing checkouts to ensure all systems are nominal. About now, Orion is undertaking its flyby of the Moon, performing a close approach to the lunar surface on its way to a distant retrograde orbit, a highly stable orbit 65,000 kilometers beyond the Moon. Orion will spend about 10 days in lunar orbit before heading back to Earth at some 40,000 kilometers per hour, eventually splashing down under parachutes in the North Pacific Ocean off the coast of California. It'll be the fastest re-entry ever of a human-rated spacecraft. Communications between Mission Control and Orion are being undertaken jointly by the Near Space Network, which is managed by NASA's Goddard Space Flight Center in Greenbelt, Maryland, and which provides communications for spacecraft in low Earth orbit, and the Deep Space Network, managed by NASA's Jet Propulsion Laboratory in Pasadena, California, which provides longer-range communications and tracking beyond Earth orbit. The Deep Space Network has 3 tracking and communication stations, located at Goldstone, California, Madrid, Spain, and at Tidbinbilla near Canberra. The Deep Space Network, or DSN as insiders call it, is currently supporting dozens of missions across the solar system and even beyond into interstellar space. It was the Deep Space Network's Canberra station which was first to make contact with Orion as it left Earth's orbit on its outbound journey to the Moon. And Glenn Nagel from the Canberra station says it'll also be the last to make contact with Orion as it returns home.
So both the Near Space Network and the Deep Space Network have been providing the two-way communications to track NASA's Artemis mission on its journey since the time of its launch and then right throughout its journey to the Moon and then the return to Earth splashdown. So particularly for Canberra, we were the first station to have contact with the spacecraft shortly after its launch from Cape Canaveral, Florida, and then we handled communications, in fact, right throughout the following day to be able to make sure that spacecraft is on its journey, a couple of the course corrections that it needed to do, and have been providing back from the spacecraft really spectacular images of its outward journey, leaving the Earth behind and the Moon getting closer in the window.
For those of us old enough to remember the Saturn V and Apollo 11 and that whole era, it does bring back memories.
Oh, it certainly does. Look, I was that 7-year-old watching Neil Armstrong and Buzz Aldrin walking on the surface of the Moon, and for me, having no idea, more than 50 years later whether I'd be sitting at the place watching, a new spacecraft heading off to the moon, getting ready to send humans back to the surface of the moon. It's been a long wait. But yeah, it certainly brought back memories of those amazing days of Apollo.
This isn't just going back to the moon. This is setting humanity up for eventually going onto Mars, because it'll be Orion that'll be doing that.
Yeah, so this spacecraft is not just designed to travel to the moon. It is a vehicle to eventually take humans off to Mars, but we need the moon as a staging post, a place to live and work for longer periods of time, building the infrastructure and the experience that we need to be able to take that next great leap 1,000 times further away than the moon to the planet Mars. That may still be another 20 years or more away. We're not in the race anymore, but we will go when we're ready. And we'll be doing it with multiple nations together. So the moon is a place where we can build a base of operations, a scientific outpost, just like we have down in places like Antarctica. Many nations working together in science, cooperating and working there. So we can do the same at the moon and use that experience to go off further afield.
That multinational approach is happening already with Orion. The service module was built by the European Space Agency.
Yeah, so the Europeans are a big part of this mission. And of course, we're using some of the best technologies developed for spaceflight over the last 50 years in this new vehicle, but with all new power systems to allow the spacecraft to stay out there for longer periods of time. Going to be building a space station in orbit around the moon, Lunar Gateway, which will take the cooperation of many, many nations, up to 15 nations, in a similar way that we've done with the International Space Station in Earth orbit.
Lunar Gateway will probably form the basis of the eventual vehicle that goes to Mars.
Yes, so for building these larger structures in space, particularly in deep space, that means you're not sort of tied down to having to get your whole vehicle off the Earth. You need an enormous rocket to launch something big enough to take a journey there. So if we can do that construction in Earth orbit, basically put our spaceship together as a station with propulsion and power modules and habitat, storage and all the things we need to go on that journey, then yeah, a much better way to do it. And even a vehicle that might not necessarily have that one use. It could be a cycling vehicle, just constantly traveling back and forth between Earth and Mars in a big elliptical orbit and taking humans there for the ride.
Now that sounds a lot like Elon Musk and Starship.
Well, yeah, but we're at that time in technology we can do it. It was actually a concept originally dreamed up by Buzz Aldrin, second man to walk on the moon. A great engineer came up with this idea for a Mars cycler spacecraft.
And not a bad boxer either, from what I hear.
Yeah, sometimes he gets a little bit annoyed by the moon deniers, shall we say.
Yeah. How does Orion compare to the old Apollo capsules?
So we're looking with the Apollo program. We're able to send 3 astronauts on a fairly cramped journey to the moon. So you've got a sort of 50% larger spacecraft here with the largest heat shield we've ever produced for a human-rated spacecraft. Be able to carry up to 4 to perhaps 6 astronauts at a time on journeys to the moon. So we just won't be landing 2 guys on the surface. We'll be landing the first woman on the moon, the first people of colour, other guys, a whole crew to do really intense exploration. And especially when we get to the point of build a scientific base somewhere near the south pole of the moon, we're going to need more than just 2 people on the surface.
And this is also where Elon Musk and Starship come back in, because a version of Starship, to be called HLS, will actually do the shuttling between what will be the Gateway space station and the lunar surface.
Yeah, so NASA has selected SpaceX out of 3 competitors to be able to provide the human landing system, HLS, to take astronauts from Gateway down to the surface of the moon. Now, of course, SpaceX hasn't had the first launch of their new vehicle do that, to even start testing that program. But they're probably only a month away before they actually do that first attempt of that launch for that type of vehicle. And behind the scenes, they are working on the human landing system. It would be a very big vehicle. In fact, for me, Stuart, it looks a lot like the types of vehicles that we had in science fiction movies of the 1950s. That great big cylindrical rocket and the big landing legs and powerful motors to be able to land it on the surface of the moon and take off again, leaving nothing behind. But the big thing about a big vehicle landing on the moon is you can take a lot of cargo with you. And that's going to be essential. If we're going to explore further afield, we need transport vehicles for the moon. We'll need to take infrastructure, power systems, putting solar on the moon, having communication satellites in orbit around the moon just to relay signals from one place to the other. So, yeah, it's some exciting times ahead. And it's a combination of those government programs through NASA, the European Space Agency and others, and, of course, the private sector who can provide that additional investment.
And, of course, Artemis-1 was carrying a number of passengers, namely a whole bunch of cubesats.
Yeah, so in the Ida stage, after the spacecraft started its journey out to the moon, the Ida stage had 11 cubesats in it. So cubesats are these small, sort of almost microwave oven-sized, compact spacecraft. They're usually solar-powered, and they sort of unfurl themselves and start their own journey. So you've got missions from Japan and from NASA sending some little miniature spacecraft and a few other private companies as well to do explorations like look at new landing systems for hitting down to the surface of the moon with tiny spacecraft, or spacecraft to look for water ice on the surface of the moon, or to even go off and do biomedical experiments. There's one called BioSentinel, which is actually carrying on board samples of DNA and human tissue so that we can see what the long-term effects of the lunar radiation environment, so far away from the Earth's magnetic field, what that will be on the human body. And that will be really important for when we're sending humans and having them working on the moon for long periods of time. What do we need to do to protect those astronauts?
That's Glenn Nagel from NASA's Deep Space Communications Complex near Canberra. And this is SpaceTime. Still to come, the first CubeSat mission to visit the moon arrives in lunar orbit, and a solar snake slithers across the sun. All that and more still to come on SpaceTime. While NASA's Artemis-1 mission was making its way to the moon, a much smaller spacecraft, no bigger than a bread box, successfully slipped into lunar orbit. NASA's CAPSTONE mission is the first CubeSat to arrive at the moon. The tiny 25-kilogram probe is now in a near-rectilinear halo orbit, a highly elliptical path that will eventually be occupied by NASA's Lunar Gateway space station when it's built over coming years. Gateway will act as a base camp for future Artemis missions down to the lunar surface. Its first modules are expected to be in position sometime after 2024. CAPSTONE, the Cislunar Autonomous Positioning System Technology Operations and Navigations experiment, is designed to study this orbit to ensure that it will be suitable for the future Gateway space station. The orbit marks a Lagrange position between the Earth and the Moon, where the gravitational interactions between the two bodies cancel each other out, thereby creating a gravitational well which could keep a spacecraft stable in position. It's the first time a spacecraft has been in this orbit, and CAPSTONE will aim to verify the suspected suitability of the orbit over the next 6 months. CAPSTONE will also perform a series of communications and navigational tests. They'll be in concert with NASA's Lunar Reconnaissance Orbiter spacecraft, which has been orbiting the moon since 2009. The CubeSat's now undertaking a series of cleanup maneuvers designed to ensure the spacecraft is inserted precisely into its correct orbit. CAPSTONE was launched on an Electron rocket from New Zealand on June the 28th. It was placed on a highly fuel-efficient 4.5-month-long trek using gravitational contours between the Earth and the Moon to reach its target. But it's not been a smooth flight. It's had a number of problems. The first saw mission managers lose contact with the probe on July the 4th, just after it separated from its electron-proton upper stage kick motor. That was eventually tracked down to an improperly formatted command, which was quickly corrected. Then, 2 months later, on September the 8th, CAPSTONE suffered another issue during a planned trajectory correction engine burn, when it suddenly began to tumble out of control, forcing the spacecraft to enter protective safe mode. That issue was eventually traced to a faulty propulsion system valve, and a workaround was developed. Of course, CAPSTONE won't be the only CubeSat in lunar orbit for long. It'll shortly be joined by 11 fellow CubeSats deployed from NASA's Artemis-1 mission. And while CAPSTONE is the first CubeSat to achieve lunar orbit, it's not the first to leave Earth orbit. That honour goes to NASA's twin Marco probes, which were deployed from the Mars InSight lander back in 2018 to study the red planet. This is SpaceTime. Still to come, a solar snake slithers across the sun, and later in the science report, meteorologists warn that Australia needs to prepare for increasing floods and droughts caused by an acceleration of the El Niño Southern Oscillation Index due to climate change. All that and more still to come on SpaceTime. The European Space Agency's solar orbiter has imaged a massive flash of plasma streaking a third of the way across the face of the Sun. Astronomers say the spectacular event was actually a surge of cooler atmospheric gases snaking through hotter surrounding plasma and suspended by a long filament of the Sun's magnetic field. The observations, which were a precursor to a much larger eruption, provided an intriguing new addition to the zoo of features revealed so far by the Solar Orbiter mission. The event, which astronomers are referring to as a solar snake, was seen on September the 5th as Solar Orbiter was approaching the Sun for its October 12 close flyby. Plasma is a fourth state of matter. While relatively rare on Earth, it's the most common state of matter in the universe. It's actually a superheated ionized gas stripped of electrons, which on Earth is commonly seen as lightning. The loss of electrons makes the gas electrically charged and therefore susceptible to magnetic fields. All the gas in the Sun's atmosphere is a plasma because the temperature here is more than 1,000,000 degrees Celsius. The study's lead author David Long from the Mallard Space Science Laboratory says the plasma snake was seen flowing from one side of the Sun to the other. The magnetic field was extremely twisted, causing changes in the plasma's direction. The observations were captured by Solar Orbiter's ultraviolet imager. The snake took around 3 hours to complete its journey across the face of the Sun, meaning it was traveling at around 170 kilometers per second. What makes the snake so intriguing is that it began from a solar active region that later erupted as a coronal mass ejection, ejecting billions of tons of plasma into space. And this raises the possibility that the snake was a sort of precursor to this event. And the good thing there is Solar Orbiter caught it using all its instruments. For the spacecraft's energetic particle detector, the eruption was one of the most intense solar particle events it had seen. And fortuitously, the eruption also swept over NASA's Parker Solar Probe, allowing its instruments to also measure the coronal mass ejection. Being able to witness a coronal mass ejection take place and then sample its ejected gases either with its own instruments or those of another spacecraft is one of Solar Orbiter's primary scientific aims. It allows astronomers to get a better understanding of solar activity and the way it creates space weather, which can disrupt satellites and other technologies on Earth. Launched in February 2020, the 1.8-ton Solar Orbiter is a sun-observing satellite designed to obtain detailed measurements of the inner heliosphere and the nascent solar wind. Its mission includes a series of gravity assists of both the Earth and Venus, which will allow the spacecraft to move out of the planetary plane of the solar system and observe the Sun's little-understood polar regions, which are difficult to study from Earth. These observations will be important in understanding how the Sun creates and controls its heliosphere, the atmospheric region of the Sun that bathes the entire solar system. In June 2020, Solar Orbiter came within 77 million kilometers of the Sun, capturing the closest observations of the Sun ever undertaken at that time. Then in March this year, Solar Orbiter got even closer to within 75 million kilometers of the Sun, halfway between the Sun and the Earth, and closer than any other spacecraft ever. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.